Utilizing vacuum and the atmosphere around us can be a very useful tool. This giant clamp is all around us, and if harnessed properly, can serve a wide variety of purposes in your shop. Hello, my name is Darrell Keel, and in this video, I'm going to explain the principles of vacuum pressing technology, show you the equipment used in a vacuum press, and demonstrate how to veneer, laminate, and clamp items using a vacuum press. Before we get into the nuts and bolts of vacuum pressing and the equipment, let's take a look at why you might consider getting a vacuum press. The number one reason for me is to utilize and incorporate veneer into my work, which opens up possibilities that I could never consider with just solid wood alone. Utilizing this material affords me design freedom and creativity. This radial match top is a perfect example, not something you could do in solid. How about this curved panel, this cylinder, and these shapes, moldings, bullnose edge? Now over to bent laminations. Here's an arch jamb and a spiral staircase stringer. Also, you can use the pump by itself as a hold-down clamp in just about any configuration with no chance of marring the surface. And when you're done, we can just disassemble everything and put it away. No other tool or piece of equipment can veneer and do bent laminations like a vacuum press can. The success of a vacuum press relies on two basic principles. The first is the sheer weight of the air around us, called atmospheric pressure. Just this small piece of particle board has over a ton of pressure on it. Because pressure is all around this board, top, bottom, and sides, it appears there's really no pressure on it at all. In fact, this pressure is being applied to me right now, and I don't feel squeezed in the slightest, which can make this concept a little difficult to relate to. Let's do a demo to show the power of atmospheric pressure so you can see just how much is all around us. What I'm doing here is putting these boards in a vacuum press. At this point, the atmospheric pressure inside the bag is equal to the atmospheric pressure on the outside. The vacuum pump draws all the air from inside the bag, creating a vacuum. As this happens, the full weight of the outside atmosphere will bear down on these boards, attempting to get to the hollow space between them. The sealed bag prevents this. Watch what happens. The second basic principle of vacuum pressing is degassing. These two buckets of food-colored water and two pieces of porous balsa wood will demonstrate degassing and vacuum's advantage over non-vacuum. I'll use these blocks to submerge the wood. Just about do it. This one, I'll just put in a container and let it soak. And this one, which is a vacuum marinator container for meats and vegetables, I'll place under vacuum. Switch on the pump, turn this valve, and the vacuum is sealed. Oh, see the way that bubbles? That's degassing right there. Degassing is the removal of air from any porous surface, and since wood is porous, this automatically happens in a vacuum. Okay. We'll check back on these two buckets in 15 minutes. When gluing two pieces of wood together in a vacuum press, the air is not only drawn from around this piece of wood, but from its pores and cells as well, allowing the glue to be drawn into these negative spaces, creating a better glue bond. Look at how much deeper the dyed water penetrated on the sample from the vacuum as opposed to the one left out in the atmosphere. Think of how this effect increases the depth of glue penetration. Combine degassing with the force of atmospheric pressure, and you have what's necessary to achieve a quality glue bond. Now that we've examined the forces behind using vacuum, we're going to take a look at the equipment required to create it. A vacuum press consists of two parts: the pump, where vacuum is generated, and the bag, where vacuum is captured. Let's take a look at the pumps first. What do we want them to do for us? There are two primary considerations. First and foremost is how much vacuum you need, which is rated in inches of mercury, which you see on this vacuum gauge. See these numbers on the side? They go up to 30 inches of mercury, which is perfect vacuum. You're looking for intimate contact between the materials being bonded and sufficient glue penetration, which varies based on the type of glue you choose. As a general rule of thumb, you should achieve a vacuum level above 20 inches of mercury with most glues you're using. The second consideration is how fast the air is evacuated, which is rated in cubic feet per minute. Between 1 and 10 CFM is sufficient for any project. The goal is to stay ahead of the glue's takt time, which, if you have a low CFM pump, can be dealt with by using slower setting glue, like this type. Now let's take a look at our selection of pumps. Your shop vac is not a vacuum pump. This is a vacuum cleaner with high cubic feet per minute, but low inches of mercury, insufficient to press a panel. You need to stick with these industrial vacuum pumps. They pull all the vacuum you'll need, are relatively inexpensive, and easy to maintain. Within this group, I've broken them down further into two categories: ones that have self-contained electric motors and ones that use compressed air to create vacuum. Let's look at the self-contained ones first. I've narrowed them down further to these three pumps, which I find are most cost-effective, low maintenance, and practical for our application. This diaphragm pump, generally from 1 to 3 CFM, the rocking piston from 3 to 6 CFM, and the rotary vane generally from 5 to 10 CFM. And they all reach the same level of vacuum. Any one of these pumps will service you well if you take some basic precautions and follow some simple maintenance procedures, which we'll cover later. Another option for creating vacuum is with this rather simple device called a vacuum generator or venturi, which works off your compressor to create vacuum. It operates like this. Connect compressed air here. High velocity air is blown down this tube, drawing vacuum from the bag here. Very simple. Now, you wouldn't want to run a vacuum generator continuously like this for an entire pressing cycle and make your compressor run almost as much. Not a good idea. Instead, this vacuum generator should be incorporated into an auto self-cycling unit like this one, which will sense vacuum and turn the compressor on and off when needed. Unlike the vacuum generator, these electric vacuum pumps can run continuously as long as they are not enclosed in a case or a box, which would cause them to overheat. Of course, you can incorporate one of these into an auto self-cycling unit just like you can with a vacuum generator. In this case, it will turn on and off the electric motor as needed. The question I get all the time is, which system is best? I recommend auto self-cycling units over continuous run pumps. Yes, they're more expensive, but by far are much more efficient, and the pumps built into them will last much longer, since during a pressing cycle, they're off most of the time. As far as electric versus vacuum generators, the question is, do you want one more tool running off your compressor, or would you prefer a standalone electric unit? It's really a matter of personal preference. One system is not better than another. Remember though, when you're doing an overnight pressing, which can happen with a slow-setting glue, a vacuum generator type system will require your compressor to be on and running when you're not there. Something to think about. Now that we've examined pumps, let's take a look at bags. A vacuum bag consists of three parts: the bag itself, the nipple or connection into the bag, and a seal. Let's look at the bag first. This would be a typical bag, 2 sheets of plastic sealed on 2 or 3 sides by heat welding. Shorter bags like this one are sealed on 3 sides, where bags 8 foot or more are usually sealed on 2 sides, allowing access from both ends. Although there are many different types of plastic sheeting, the 2 common materials used for vacuum presses are vinyl and polyurethane. This vinyl has some elasticity, acceptable but not great. I'll use this pen stood up in a block to show puncture resistance. This has medium resistance, but I can get through it. Here's the polyurethane. Good elasticity and excellent puncture resistance. In fact, I can't get this pen through it at all. Of these 2, polyurethane is the clear winner, so why even consider vinyl? The answer is cost. This polyurethane is over double the cost of vinyl. I break it down this way. If you run a professional shop and will use the press regularly, I recommend this polyurethane. If you're a one-man shop, occasional user, or hobbyist woodworker, you may be happy with this vinyl. And another thing about polyurethane versus vinyl. All vinyl bags will, over time, tear along this heat-welded seam. Polyurethane will never do this. So if you're planning on doing a lot of curved work, which will end up putting more stress on the seams, I recommend getting polyurethane. Both this vinyl and polyurethane come in 20 or 30 mil. In my opinion, always get 30 mil. You'll get considerably better puncture resistance, and the reduced flexibility is minimal. It's really durability that you're after. As far as the vacuum port goes, there are 2 types. One that is molded permanently as part of the bag, like this one, and the one that you install into the bag afterwards, like this one. This one can be placed wherever you like and can be easily moved, but it is a little more prone to leakage as it's not molded into the bag. This type, which is molded into the bag, has a great seal, but of course is in a fixed location. You can get a nipple patch kit like this and move the nipple to a new location when this end of the bag wears out. For sealing the bag, this tube and C-channel closure is the common method. I've tried Ziploc type closures, but glue and chips tend to get caught in the zipper and cause the bag to leak. Therefore, I don't recommend bags with this type of closure. All right, now that you've seen the individual components of a vacuum press, let's set one up and do some pressing. Once your pumping bag is ready to go, the last thing you need to make to set up your system is a platen. This platen serves 2 purposes. First is to get the air from all corners of the bag through these grooves down and out through the exit hole. The second purpose is to have a surface to slide your panels in and out on top of so you don't damage your bag. This is a piece of 3/4 inch MDF that will become our platen. Platens should be made out of MDF or particle board, not plywood, as plywood traps air in the inner layers and leaks out slowly. The porosity of MDF and particle board allows the air to be pulled out evenly. I prefer melamine coated platens like this one, so excess glue squeeze out won't stick to it. The first thing we need to do is drill a hole here where the hose to the pump will connect. Drive this platen sleeve in and cut it off flush on the top side. Next, run 1/8 inch grooves about 12 inches on center, making sure a groove in each direction cuts through the platen sleeve. The air will follow these grooves down to the exit hole and out of the bag. One last thing, I'm going to soften these sharp corners. This will help prevent the bag from being punctured. Now that the platen's complete, let's set up the press. This sleeve in the platen receives the brass tube on the hose by sliding it up through the nipple and into this sleeve. This locks the board and the bag together so there's no stress on the nipple. Now we'll give this a quick test run. I like to do this before I spread glue, just to make sure everything is set up and running right. Discovering a hole in the bag or a malfunction with the pump when the panel is covered with glue is an experience I like to avoid. In an auto-cycling system, when the proper vacuum level is reached, the pump automatically shuts off and cycles only when needed. This pump is functioning as it should, and this bag is holding vacuum just fine. Let's get ready to press the panel. Here I have an MDF panel, 2 cauls, and 2 pieces of veneer. The face veneer is a 4-way match of madrone burl with veneer tape to hold these 4 pieces together until they're pressed. Just like 2 boards, veneers have to be cut straight to put them together. The way this is done is to lay one piece on top of another, take a straight edge, put it on top of the veneer, clamp it down, and run this veneer saw along the straight edge until you cut through both layers of the veneer. This will give you a perfect edge that you can then tape together and have a seam that is invisible. The next step I need to perform is to hold these 2 pieces together. And the way that I do that is with this masking tape first on the back side. And I pull the joint together, putting the tape down on one side, and then drawing it in a pulling motion across to the other side. Once I have that done, I flip the veneer over, and with this veneer tape dispenser, which has a little roller here that is in a trough of water, I pull the veneer tape over that, and then when it's wet, I place it down over the veneer and rub it down. If you don't have one of these fancy veneer tape dispensers, a wet sponge will do the job. The last thing I need to do is to flip this over and remove this masking tape. The masking tape is just temporary. You wouldn't want to accidentally bury it into your glue joint. There. This is how you prepare 2 pieces of veneer or more for pressing. In this demo, I'm using these 1/8" melamine-coated masonite cauls. Cauls are always needed between the veneer in the bag and the veneer in the platen. This caul that goes between the veneer and the groove platen will prevent the glue from sensing lack of pressure at these grooves, which would leave small raised areas in the veneer wherever a groove is. One other thing, notice that the caul on top is the same size as the panel, whereas the one underneath is larger. The one on top can't overhang the panel any more than it is thick, or you risk snapping the excess off. The caul on the bottom does not have this issue, so it can be any size up to the size of the platen underneath. I prefer melamine-coated cauls, so excess glue squeeze out won't stick to it. If you can't get your hands on this material, then just put a sheet of drop cloth plastic between the veneer and a caul. Because veneer is often buckled and prone to wrinkle when glue is applied, this top caul creates a leveling pressure between the bag and veneer. This assures uniform contact between the veneer and substrate. Now it's time to spread glue. Before we do that, let's take a look at the choices. There are a lot of different glues to choose from, as you can see from the selection I've laid out here. When you glue two boards together like this, you basically ask that they stay bonded to each other. And that's about it. When you glue this veneer to this substrate, you also want them to stay bonded to each other, but you want something else, that the veneer will not expand or contract. Veneer, by definition, is wood cut thin enough that when pressed to a stable substrate, the glue it is pressed with has the power to overcome seasonal expansion and contraction. With this definition in mind, let's look at the glues I have set out here. I have put them in three categories: what I call flexible, semi-rigid, and rigid. In the flexible category, I have contact cement, solvent-based, and spray-on. In the semi-rigid category, I have all PVA glues: white, yellow, and even one colored brown. In the rigid category, I have true catalytic glues: epoxy, polyurethane, and urea formaldehyde resin glue. There are, of course, other glues, but these represent the most common glues used today for veneering. Now, along with each grouping of glue, I have these samples that I poured out on some plastic sheeting some time ago and let completely dry or cure. I think they reveal a lot about the glue's properties, at least the important property we're looking for: the ability to overcome seasonal expansion and contraction of the veneer. It's hard for me to see how this contact cement, being more flexible than the veneer itself, is going to possibly hold this. Not my recommendation for veneering at all. How about this sample in the semi-rigid group? Definitely more rigid than the contact cement, but still a fair amount of flexibility. Now let's look at this urea resin glue from the rigid group. Now that's what I call rigid. With our definition in mind, I think this glue is the clear winner, and this epoxy is a close second as well. This doesn't mean a PVA glue isn't acceptable for veneering, because it is. There are times, though, with, let's say, this mahogany crotch, which is extremely fragile and difficult to work with, or say, a tabletop that will receive a high polish finish, where I'd use the most rigid glue I can get my hands on instead. Glues that bond and cure by chemical reaction will always give you the most rigid bond. Okay, now that I've chosen the appropriate glue, I have everything I need, including a foam roller, excellent for putting down a nice even glue line quickly, and this paint pan to put the glue in. Pour some of this glue out, add the right amount of catalyst, and mix. Now spread glue. The main question is, how much to apply? See this area here? Too much glue. It's almost a puddle. This area up here doesn't have enough glue. It's almost dry. I'll even this out to get the right balance. Now this is about right. Now I'll put the veneer on this side. Then flip it over, face down on this caul. Start rolling glue on this side. Always veneer both sides of a panel at the same time. If you don't, the panel will end up warping from the imbalance. This side is ready. Put the veneer on, cover sheet, okay, and a little tape to hold the sandwich together. Slide this in the bag. Put on the closure. Turn on the pump and let it run up to full vacuum and shut off. We'll let this sit for a couple of hours and then be back. Here's that squeeze out we're looking for. See those little beads of glue? That would be the ideal amount. By the way, the pump we're using has the 6 CFM rocking piston in it. That should give you an idea of how fast this pump drew the air out of this bag. One last thing. Urea resin glues require a minimum temperature generally around 70 degrees. This is going to sit overnight, and I want to make sure I meet that minimum temperature. So I'm using this heating blanket to keep the temperature in the optimal range. All right, this will keep this nice and toasty all night long. Here we are the following day. Let's take this panel out and have a look. Turn off the pump. Looks great. This side looks good as well. Okay, now that this veneer is pressed, I'm going to use this simple envelope licker to remove the tape. I'll wet the tape like this. And now wait a couple of minutes. Now that this water has soaked in for a couple minutes, the glue has released this tape and can be pulled off for the most part in one nice easy pull. Here we go. Because there's a little glue residue left, I'm going to take this sponge and just scrub this area. Now we're ready for the next stage, which is scraping and sanding. Let's talk about curved work. One of the wonderful things about a vacuum press is its ability to press curved panels. All you need is the mail form, like this one you see here. In fact, I made this curved panel on this form. The first thing to be aware of when you're constructing a curved form is making sure it can withstand the full force of vacuum. Remember the demonstration at the beginning of this video? That's the kind of force you're dealing with. To construct a form that will withstand this level of pressure, as well as not deflect under it, a series of ribs combined with a stiff skin is required. This material, called 3/8 bending ply, is the ideal skin for curved forms. As you can see, it's quite flexible in this direction, but very stiff this way, making it the perfect choice. I'll place my ribs on top of this 1/4-inch plywood every 6 inches on center like this. If this form were to be taller than 6 inches, I would need to internally brace the two ends with blocks, or else this form could implode under pressure. Now it's time to put down 2 layers of the 3/8 bending ply for a strong, stable, zero deflection form. All right. Now that the skin is on, make a saw cut in the bottom of the form to allow the air to get out from inside of the form as fast as the pump wants to remove it. The cut should run perpendicular to the ribs, just high enough to cut through the 1/4-inch bottom. Now that we've finished the form, let's take a look at the composition of the materials that will be pressed on top of this form. These are the 3 most common materials used for curved work. The same 3/8 bending ply we used on the form, 1/8-inch bending ply, and kerf-cut particle board with a layer of 1/8-inch bending ply on top. All of these have enough flex to bend and hold to the form accurately after pressing. Here, I'm using a combination of 1 layer of 3/8 bending ply for the middle and 2 1/8-inch bending plies for each side. This makes a smooth quality surface, and the 3/8 material builds up the thickness quickly. Okay, we're ready to go. I have my bendable plywood, panel, glue, foam roller, and a paint pan. Now, I prefer to glue up the core first and then come back in a second pressing and put on the veneer. Pour the glue. In this case, I'm using a regular PVA yellow glue. Spread it on the 3/8 bending ply. Apply one of the 1/8-inch bending plies. Spread the glue, and then the other 1/8-inch bending ply. Put it on the form like this. Place a couple pieces of masking tape, like so, to hold it roughly in place. Now it's ready for vacuum. To make sure everything stays lined up properly, I'll hold it here until the vacuum takes over. There, we're all set. Notice that the bag is considerably bigger than the platen for this pressing. Because the bag has to accommodate the additional height of this form, I need more room for it to get up and over without the platen restricting this. When you're doing curved work, you need more bag or smaller platen. Notice how long it took the pump to turn off for this pressing. Even for this curved panel, which has more air volume, this 60 FM pump still did a fine job. Okay, it's been a couple of hours, about what I would leave a curved panel in for when using yellow glues. Let's take it out. Sitting nice and tight on the form, no gaps. Before I take it off, I want to do one thing. Make a mark here on the form and on the panel. When I put this panel back in the bag with the veneer, I want to be sure it's in the exact same location so I know the panel and the form will mate perfectly. Now this curved panel is ready to be veneered, but let's do it a little differently than with the flat panel. I'm going to use what's called a 2-ply. A 2-ply is simply 2 pieces of veneer glued to each other at 90 degrees, like this. Sanding and scraping veneer on a curve is much more difficult than on a flat, especially inside radii. This 2-ply is now stiff enough to sand before veneering. Use double-faced tape to stick it to the bench. scrape and sand away. So when you put it on the panel, all but the finish sanding is done. Okay, here we go. We have our curved panel, our form, 2 sheets of 2-ply veneer, one for the front, one for the back. Remember, we always have to have balanced construction. I can't put a single veneer on one side and a 2-ply on the other. We would risk warpage. Spread the glue on the back side first. Put on the 2-ply. Place the panel on the form, making sure the 2 marks line up. Then spread the glue on the face and put on the other veneer. I'll apply a little masking tape here to hold everything in place, then put it in the bag. Notice that I'm not using a caul between the bag and 2-ply. Because the face veneer has already been glued to the backer veneer, it is stabilized and can no longer wrinkle or buckle, making the caul unnecessary. Okay, it's been a couple of hours. Let's have a look. There we are, nicely done. The last step would be to cut to size and put on some edging. You know, another great thing about a vacuum press is when you're done, you just roll it up and put it away. Doesn't take up any space at all. As practical as vacuum pressing is for veneering, it's equally as useful for bent lamination work. In this demo, I'm going to press up an arch jamb, and I'm going to use a method I call the outside technique. With the curved panel we just laid up, both the form and the panel we were bending went in the bag. I call this the inside technique. With the outside technique, only the laminations go in the bag. The form stays outside. Let me demonstrate. I have my laminations here. 5 layers of an 1/8" solid wood. A vacuum bag. This one is long and narrow, meant just for bent lamination work. Also, a bleeder fabric I call a vacuum net. I'll explain more about this in a minute. And my form. With the outside technique, you can get away with using a very lightweight form, since it won't go in the bag and won't have to withstand the pressure of vacuum. Okay, I have everything I need here. Let's lay this up. Spread the glue on the laminations. I'll use this stretch wrap to hold the laminations together. Put the vacuum net on top, tape it down, and slide it all into the bag. Now I'm going to measure here and put a mark which represents the center of this bent lamination, so when I put it up on the form, I'll know where top center is. Make sure the nipple on the bag is over this netting. Because I don't use the regular platen we used in the other bag, I need a way for the air to get down to this exit nipple. This is the purpose of the bleeder fabric. The air flows down this coarse weave and out the nipple. Another option is to make a bendable platen like this. This is a piece of 3/8 bending ply that I put the usual grooves in and doubled up with a small block around the nipple location on the opposite side. So here we are with the laminations and netting in the bag, flat on the bench. Draw a light vacuum on the bag to sort of shrink wrap the whole package together and to prevent the bag from wrinkling when it bends around the form. Now, line up this mark with the top of the form. Attach a clamp with a block like so. This temporarily holds the laminations in place. Bend this side down. You have to do this. Vacuum will not draw this to the form. I'll clamp it here. Do the same on the other side. Okay? Looks good. Turn on the vacuum and let it cycle up to full pressure. The benefit is twofold. Obviously, you don't need a heavily built form, and getting a large form like this into a bag would be somewhat difficult. I don't tend to use this method on smaller parts or parts that have to mate very accurately to the form. Although, as you can see here, it's sitting pretty tight. There we are. It's all done. And look at this. There's virtually no clamps. We only have clamps on the end holding it to the form. It's the atmospheric pressure that is the clamp on this bent lamination. When I do bent laminations, I always like to let them sit overnight to minimize spring back. Let's take a look. That's looking pretty good, sitting pretty tight to the form. All right, let's take it out of the bag. Here's a little trick to get the laminations out. I'll blow some compressed air in here. And there we go. The laminations are nice and tight. Let's put this back on the form and check it. As you can see, there is a little bit of spring back, but because this is an arch jamb, when I put it in the opening, I can push that down without any real trouble. I've shown you how a vacuum press is used for flat and curved work, as well as bent laminations. Now let's take a look at it for a much different application, holding parts, or what's called vacuum clamping. Using a vacuum press without the bag to clamp parts can be very useful. Clamping with vacuum leaves no marks on the workpiece, and it allows all but the underside of a piece to be exposed for your working area. This makes it a very versatile clamping tool. Let's set one up and do some clamping. I have two kinds of vacuum clamps here. One you would make from scratch and a pre-made manufactured one. The homemade one is pretty simple. The only thing you really need is an adhesive back closed cell foam tape like this one, which in this case is an 1/8 inch thick by 3/8 wide tape. Thicker is not better. It only makes things a bit squishy instead of nice and solid. Also be sure it's closed cell foam. I'm going to use this piece of melamine coated particle board as my table surface. You need a completely non-porous surface to achieve good vacuum level. I'll take this tape and create an enclosed space like so. Put one or more pieces in the center to keep the part from dishing in the middle. Drill a hole for the vacuum. Put in this plastic sleeve for the vacuum hose connection and cut it off flush. Leave this edge overhanging for the vacuum hose and attach it underneath. Clamp it down. Now you're ready to turn on the vacuum and place the part on top. Because this wooden part has too much porosity, I'm going to run the pump in continuous mode. If I ran it in auto cycle mode, the pump would come on and off too much. Place it on. It is rock solid. Let's do some scraping. I also have unobstructed access to all the edges as well. Let's do this same demo with an open cell weather stripping. Most hardware stores and home centers carry both weather sealants, which are closed cell, and weather stripping, which is open cell. As you can see, this board is not being held at all because the air is escaping sideways through this open cell stripping. Here's one I made earlier for horizontal work, as well as vertical clamping, sort of a vacuum vise. Do my horizontal work here. And vertical holding here, like so. Here's a two-sided clamping jig. One side sucks to the table, the other to the workpiece. This type of clamping device needs to be completely non-porous throughout, not just on the surface. I made this one out of pine, which is surprisingly non-porous. A hole drilled through to both sides here, and an intersecting hole on the edge where the vacuum is connected. Just put the workpiece on top, push down. The workpiece clamping jig and the workbench are all drawn together simultaneously. These manufactured clamping pods have an additional feature on the two-sided type. I can position these pods where I want them. Draw them down to the workbench first. This little valve prevents the vacuum from entering the top of the pod until I press the workpiece down like this. A handy feature. Check this out. This is a circle cutting jig that I can clamp down with vacuum. Let me demonstrate how it works. This centerpiece holds the jig to the table surface, and the router arm pivots on the hose connection. This is just one of a whole bunch of jigs you can come up with using vacuum. Maintaining your vacuum press is pretty simple. It's basically a pump and a bag. Not too much that can go wrong. There are a few things you can do to keep it running smoothly. One important regular task is to always purge the system when you're done pressing. A vacuum pump is a natural moisture extractor. Moisture vapor from the glue is drawn down into the vacuum chamber, and if it isn't purged, it can cause corrosion over time. Simply leave the pump on and open up the bag. This automatically pulls fresh, clean air down into the pump. Let it run for a few minutes. This way your pump will be put away clean and dry. Check your filter jar on a semi-regular basis. Dust and chips will get sucked down into the filter bowl and over time clog up the filter element, slowing down the pump's evacuation rate. Simply empty the bowl and blow the dust and chips off the filter element. One thing I do for bag maintenance is to put this vegetable spray on the bag right where the closure goes. This helps to keep the glue from sticking here. Keeping it extra clean will prevent the pump from cycling more frequently. Now let's examine some of the more common problems that can happen with a vacuum system. Sooner or later, every system is going to develop leaks. If you have an auto cycling system and your pump is cycling in under a minute, then it's time to check for leaks. Test the pump separately from the bag to see if it's holding vacuum well. Pull the hose out of the bag, put your thumb over the end of it, and turn on the pump. If the needle just sits there, you're fine. This one does. But if yours doesn't, check the filter jar gasket. And if you have a quick disconnect like this, examine the O-ring. With bags, leaks can be difficult to find, but I'll show you a few tricks to track them down. Wipe down the bag with water where the closure goes. Just doing this can improve cycle time considerably. Get right here in the corners too. As far as locating leaks in the bag, simply listening for them can help. Here's a sort of homemade stethoscope I use for locating leaks. Suck the bag down, turn off the pump, and listen. Another handy way to find leaks is with a little bit of food coloring and a sponge. Let me show you. I'll make a little hole here to demonstrate. Ouch! This just seems wrong to do. Take this sponge with food coloring and wipe it over the hole. Look at the way the liquid is drawn through. Very handy for finding leaks. Let's talk about another troubling situation I call flow restriction. Flow restriction is an airflow blockage between the pump and the bag. I'll create one so you can see what happens. To do so, I'm taking a little bit of this paper towel and stuffing it in the exit hole of the platen. The extra air volume of this form I'm putting in will help to dramatize this flow restriction better. Look at what happens. Once the bag sucks down around the platen, the pump reaches full vacuum and shuts off. Watch the gauge. Immediately, it drops below the turn-on point and the pump struggles to come back on again. This is bad for the pump. If you have this scenario, look at the exit location in the platen. Make sure there are no glue or chips here. Look for restrictions at the filter jar or in the hose. blow it out. Be sure the air can flow freely. One last thing. What if you don't have any leaks and your pump won't pull full vacuum? Then it's time to examine your pumps. If it's a rotary vane type, you need to check the vanes. Are they loose and free in their slots? If the pump has corrosion buildup, vanes can get stuck, retracted into their slots. If that happens, pry them out and clean the chamber with some fine sandpaper, like 400 grit. Never use any oil in an oilless rotary vane pump, or this will be the death of it. With rocking piston and diaphragm pumps, the problem is usually with the reed valves. Either something is stuck in the opening or a valve got bent when a foreign object bounced around in the chamber. Examine the reed valves carefully. This compressor-driven venturi has no moving parts, but foreign objects can still get clogged inside. Corrosion can build up inside these pumps as well. To clean this unit out, simply remove the muffler and blow compressed air backwards through the unit like so. Also, blow some compressed air through the vacuum port. That should do it. Remember that hole we made in the bag earlier? Let's take a look at patching it. There are basically two options to patching a bag. Sticky back patches and some of the bag material and glue. Because this is a really small little hole, I think we can use the sticky back patches. To prep the bag for patching, I always use a little acetone and wipe the area where the patch will go. If this was a larger hole, I would use some of the actual bag material to patch the hole. I would take some of the same acetone and I would wipe the patch, same on the bag. I would spread some of this adhesive on the patch. This is a flexible urethane. Then I would simply put the patch over the hole, put a block of wood on top, and just lightly weight it, like with this acetone. I'd wait 12 hours and this patch would be glued. Well, that just about does it for vacuum pressing made simple. I hope by watching this DVD, you've come to see that the process and the equipment is really less complex than you thought. Because in reality, using a vacuum pump and a bag is really quite simple. In fact, that's the beauty of the system. A pump, a bag, and the air around us couldn't get much simpler.